Okay, I want to give you guys more of an in-depth decisions, details, all that stuff on this build compared to what I do on my Instagram account. So as you guys have been following along on my Instagram, I've cut off all the brackets on the Ford SuperDuty 60. It's really close to starting to weld stuff up on there. Today I threw it under the truck, centered it up, kind of see how I like everything. So this is how the axle looks at probably what would be called full bump, if this is where I'm gonna have it, but this is as high as it can go, pushed out as far as it can go. So it just clears this cross member. Ideally, if I kept it in this spot, I'd probably shave down this part of the cross member just a little bit to get more clearance in there. But one thing different about this housing is this housing is shifted to the pumpkin is shifted to the driver's side more than what the second gen Dodge one was. And I was worried about it fitting in the frame, but the truss actually fits in here extremely well. You can see how it just clears everything, the engine, the frame. So if you wanted to go high and you wanted to go use a SuperDuty axle, it would honestly work great. But to give you an idea as well, so if we use this as a reference point, and I don't know if the factory axle, but I would assume it pretty much centered in here. This axle is about 3 inches forward more than the factory axle. And I don't know if I'm gonna go that route. If I bring it forward more, I obviously have to not go as high, and I'll have to figure that out later. But mainly today, I'm kind of getting a visualization of what I need to do. And then at the same time, I wanted to figure out pinion angle and then casters, see if I needed to turn the C's at all. So that's what I'm calculating today and trying to fit up, because in the next week or so I want to start welding on this axle and getting everything done. Most people do 3 links on this axle or a triangulated 4-link. I am going to stick with my long arms. I'll have to modify them to get it to work exactly, but just use the bracket still, one right here, one right there. Those will have to be made by myself, not something that you can just buy for this axle. So that's what I'm keeping. And then I've already gone over my steering box, so I am going to shift the steering box back rearward about 2 7/8 of an inch. I'm going to keep a forward facing pitman arm. Obviously that's not a factory Dodge component. This one is for mock-up. I'm having a steering box built right now with the Dodge box, but doing a reverse worm gear, which is going to point that pitman arm forward. So can't wait to show you guys that. All right, so the other thing I want to show you, since I magically pulled this out from under the truck, is this is my process of putting a Jana 76 build in this thing. So what this is a Dana 70 high pinion ring gear, and obviously a SuperDuty Dana 60 housing. I've clearanced everything, so as you can see, it does spin freely in there. I'm about to pull this out, and I'm going to go over why I'm doing this and some other features with this as well. So hold on real quick. Okay, so I have the carrier on the bench now. I have it right next to the 60 carrier, but I want to go over kind of what I'm doing. This is a Jana 76 build, and what's going on here is I have a Dana 60 carrier and ring gear, and this is a Dana 70 carrier and ring gear. So this is going in that 60 housing of what I just showed you spinning around in there. Now, the reason why you want to do this is going to be a stronger gear set. If you're looking at the teeth between these two, you can definitely see that these teeth are larger on this ring gear than this one over here. So that is going to give you more strength, but in Dana specs themselves, when you look at their spec sheet of a Dana 60 axle compared to a 70 can take 2,000 more foot-pounds of input torque going into that pinion shaft. So there is more strength there. You're getting a bigger contact patch. The other part of this is a Dana 60 pinion, 29 spline pinion. You can see how size it is. Now the 70s also have a 29 spline pinion, but since this is a Rock Jock 70 gear set from Curry Enterprise, the 70 high pinion that they make is a 35 spline pinion. So you can see that difference between the two. A lot of high horsepower guys who give it a lot of go right off the bat, they have snapped these pinions right off of there. So this is going to negate that issue quite a bit. You can think of it like going from 30 spline axles to 35. Everyone knows that there's a big difference there. So 29 spline, 35. So you gain a lot of strength in the pinion. You're gaining a bigger contact patch because just the teeth are a lot bigger on this ring gear set. You're going from a 9 3/4 ring gear size, which some Super 60s nowadays and even aftermarket gears do make a 10-inch Dana 60 ring gear, where this is 10.5. So it is a larger ring gear set. And then the other thing I want to talk about is a load bolt. So I mentioned this on the gram a little bit of me installing one. Some people had questions, not sure what it was. But what I want to get into is the different faces of these teeth. So there's a drive side, which is this flat side, and then there's the coast side, which is this more ramp side. But basically in a high pinion, when you're going forward, and the reason why high pinions are more sought after is you're pushing on that drive side, so the flatter part of the tooth. In this gear in reverse, or in a low pinion front differential in the forward direction, you're pushing on that ramp side, which is the coast side of the gear. It's not as strong, and I'm about to go into why. I'm gonna flip this gear over and talk about what this load bolt is doing. So now this is the back side of the gear. You can obviously see it overhangs quite a bit, where even on this one, it slants down. So Curry did this on purpose. The gear itself is pretty square on the edge for what it is for a gear set, but they have this flat face, and I had to machine this differential down a little bit, and all I did for that was I put the bearings on it, I threw in the housing, I spun it, I used the grinder, and then took off maybe a little over 1/8 of an inch on this. But you'll see a lot of videos on YouTube of guys doing this to slim down their ring gear for the shave kits on the differential. So they do it that way. That's what I did on this. But what we're gonna do is we're going to install this bolt, and this, so in the housing, the ring gear is in this area. This is going to get installed right about there. And once I drill a hole in there and get this welded in, this will sit about like this. So the purpose of this, and I'm going to link the videos in the description as well, is Jans Engineering. They were measuring the deflection of torque when you input it in an axle. Now they were studying 2,000 pounds of input torque, which isn't much. 300 foot-pounds of torque going through at least a 47 RE, which is first gear is 2.45 to 1. And then go into a transfer case, which is 2.72 to 1. That's at 2,000 input pounds. So 300 foot-pounds of torque is going to be 2,000 input pounds into this pinion gear. So when you're on this drive side, the flat side going in forward on a high pinion, he only saw about 0.02 of an inch of deflection in there. But when he went in reverse, so 300 foot-pounds engine torque, 2,000 input, on this coast side, he saw 0.03 of an inch. And if you've built differentials, you know the backlash in what you're trying to create in here, it's thousandths. So the Dana 60, I'm just ballparking it somewhere between 6 and 10 thousandths of an inch of what you want on backlash. And then you think in reverse, with only 300 foot-pounds of engine torque in first gear, I'm seeing 0.03 of an inch of deflection in there. So when you set up this load bolt, when it's actually in the axle, it's going to be off 0.03 of an inch. So it's going to be hovering most of the time like that. And then when I am in reverse in this axle and it does want to deflect, it has a backstop, so it's not going to deflect a lot, keeping that pattern in check as much as possible to hopefully give me a lot more strength. So that is what a load bolt is. That's why you want to do a load bolt. And we'll see. I mean, I got to throw it in here. I've got to cut the hole. I've got to still install the pinion slinger. Just in here, clearance a little bit on the back, and then on the top here. But I got a clearance around here just a tad for the pinion oil slinger. You're not going into the actual bearing pocket. You're still staying on the outside of this chamfer. But that is the next step. We'll see how long this lasts. We'll see how good it is. This is my 5th gear install. I would not do this on a first gear install. There's just way too much to think about. But wanted to give you the update on everything. That is what a load bolt is. This is a Jana 76 build. And give me a comment if you have any questions.